So this use of the vertical bar to mean or, when you take two or more rules and put them into one line. So for our grammar G1, so here we have two rules, two substitution rules. They have the same variable on the left hand side, both in the A. So we can rewrite these two rules in one line. You just use a single line by using the vertical bar. Okay, so this way. So A gets substituted by 0A1, or that's the vertical bar, or A gets substituted by B. Right? So see the vertical bar as or. All right. Second example of a grammar, and this time the context is going to be a very small subset of the English language. Okay? So we're getting sort of a little bit literary now. Okay, now it's a context-free grammar. So effectively the left-hand side of your rules has only one symbol. That's another way of defining, I suppose, context-free. There's no context. You don't. You're looking at just one variable, and you substitute that for whatever's on the right hand side of your rule. Okay, so so in this context we'll be talking about verbs and noun phrases and verb phrases and whatnot. Now there are quite a few. If you study linguistics, structure of language, you may be familiar with these terms. Now, they're rather long-winded, so when we come to write out the substitution rules, I don't want to be writing out these long, with many letters. So that's me. Sipser did not do this. This is me. I'm just saving myself a bit of work and space. So I just shorten the word sentence to just S, a noun phrase to NP, a verb phrase to VP, a complex noun to CN, a prepositional phrase to PP, complex verb to CV, a preposition to a P, an article to an A. An article is like a or the, okay, an article. A noun to N, a verb to V. Okay, so we're talking about grammar G2. It's our second example of a grammar. So listing now the substitution rules for this grammar. Now, how many rules are there? Now remember the bars, right? So for this here, there's one bar, so that's two rules. So two here. So each bar, you add a rule. So how many rules total do we have? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 rules, substitution rules in this grammar, G2. And how many variables does it have? Well, I'll just count these ones. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it has 10 variables. Remember the convention in for this chapter, text in fact, the variables are represented by a capital letter and the terminals are represented by a small letter. Well, in this case, words. Well, no, they're actually letters. Okay. Right, so 10 variables here, 10 of them, written capital letters. How many? 27 terminals. So 26 on just the alphabet, the ordinary alphabet from A to Z, and the 27th one is a blank, like a space. And that space is useful to separate words. Right? Words being just a sequence of terminals, meaning letters of the alphabet. Right? So, okay. And we had 18 rules. Okay. So this language, this grammar G2, what language, L of G2, what language does it generate? Well, sentences basically, but of strings. Remember, a language is just a set of strings. So the type. Well, here's some examples of strings that this language contains, or said another way, here are some examples of strings that the grammar G2 generates, creates, builds. Okay, so a boy sees, the boy sees a flower. Okay, a girl with a flower likes the boy, blah blah blah. Right. So the whole set of possible strings like this, and here are 3 examples. All possible strings, that would be the language L of G2. Right? So let's do the derivation of the first example. That was our boy sees. Right? Let's derive that. How to use the substitution rules to derive this string of terminals. Right? Well, actually I've got capitals here, but here I've used little letters, being stricter. Okay, and with space. So you got a space here, space, and 2 spaces, so that the words are more visible. Now, I live in China. The Chinese don't do that. They don't use spaces. They just ram all their Chinese characters together. And so for a novice, that creates a problem. It'd be a lot easier if like there were a little dot or something between the words. Typically in Chinese, you'll use 2-3 Chinese characters for one word. But Chinese don't use separators. They don't have blanks. They don't indicate where one word ends, the last character of the previous word, and where the next word starts. In other words, the first character, Chinese character, of the next word. No separator like that. No blanks, no dots. Just form rammed together. Okay. Alright, so let's derive this this string, a boy sees. So here's the derivation. So S. It's going to be a bit of I'm going to have to get out of the picture because we need the two squares. Alright, so here's the derivation of, we start in the start state, S, okay, and we're going to derive this string, our boy sees, using the substitution rules. And we have 18 of them. Alright, so here's how it's done. So we go from S, arrow, to noun phrase, verb phrase. NP, VP, just because it's, that's me, it's not Sipser doing this. I'm just using it's just so much easier. Okay, so which rule are we using? We're using this one. S goes, S is substituted by NP, VP. So S goes to NP, VP. And then we look at up variable in what we've written down. So currently what we've written down is NP, VP. Right? That's where we are currently in our writing down. So we then choose one of these two, there are only 2 choices, and we choose one of these two to substitute. And remember, you can only substitute variables, right? You cannot substitute a terminal. Terminal, that's the end of the line, the terminus, right? It's a terminal symbol. It cannot be substituted or expanded. Right. So choose one of these. Let's. Okay. So say we don't choose that one. So VP just stays there at the next step. But so we substitute NP for CN, complex noun. So there must be a rule, NP arrow CN. NP arrow CN. It's this one here. Okay. So we substitute NP for CN. NP becomes CN. Alright. Now what do we do? Still don't change this, so that just stays there. But now we substitute CN for AN. Not AN together, but AN. So so you've expanded Cn into two variables.